Hello everyone, my name is Rick Malava. My nickname in the Simply Maya forums is CTB-RAM, and I've put together this little video because one of the users on the forum, or in the forums, Max Milano here, asked if somebody could explain what rebuilding curves and surfaces and why it's important in Maya. Now, Maya has three different types of modeling methods that you can use: polygons, subdivision surfaces, and NURBS. And NURBS stands for non-uniform rational B-splines, which is just a scary way of saying that you can describe a curve or a surface as a function. And in fact, more specifically, as a parameterized function. And rather than go in the video here into a lot of detail on that, in the actual post, if people are interested, it's in the Maya Basics and Newbie Lounge. I describe a little bit about what parameterization is about. So once again, it is a mathematical way of describing a curve or a surface that's based on something called non-uniform rational B-splines, which is sort of similar to Bezier curves, and it's related to Bezier curves in a way. And if I go into, I have a little link in my response, and it kind of summarizes what parameters are and what parameterization of a curve is all about. A parameter really is just describes your position along a curve or a surface. So in the case here, a curve starts with a parameter of 0, and as I move along this curve, my parameter along the curve is 2.3. Now, there are two different ways that we can describe parameters along a curve in Maya. One is uniform, and the other is chord length. And rather than get everybody confused about the difference between the two, I'll just say what the importance of the two are. Uniform parameterization means that the parameters along the curve are uniformly distributed, and they're nice, even integer values at the start and the end of the curve, or the start and the end of the U and V direction of a surface or a patch. Chord length parameterization has non-uniform or irregular spacing between the edit points along the curve, and they don't have to be nice, even integer values. And the real importance, or the real difference between the two, is that chord length parameterization takes longer to compute but is more precise than uniform parameterization. The reason that Maya primarily uses uniform parameterization is because it's designed for the entertainment industry, and it doesn't need to have the kinds of precision that you would get in one of the graphics packages that's designed for making car surfaces or car bodies, or used in the aerospace industry. The reason that chord length parameterization is included in Maya is that if you want to move a model back and forth between Maya and one of the more precise modeling packages, CAD packages that you would use in the auto or the aerospace industry, chord length parameterization is included so that you can bring the models in and they'll behave properly. So that's kind of the difference. That's kind of what the two types of parameterization are. You'll be using uniform parameterization for most of what you do in Maya. Now, so that answers, there's two parts to Max Milano's question: what is parameterization? And that kind of describes that in a nutshell, and once again, that link is a very nice link to go to. It really describes what parameterization is in an easy way to wrap your head around. Now, the next question is, why is parameterization important, and why do I have to build and rebuild curves and surfaces in Maya, and how are the two related? So the easiest way to describe that is I've got this little demonstration that I'll do here. I might have to split this up. I'm going to try to stop about 10 minutes, and I may be going a little long because I'm already up to 4 minutes, and I'm just getting into the part where I'm going to show the what parameterization is all about, and how why rebuilding surfaces and curves is important. So what I have here is a 3-degree curve. Now, Maya allows you to build curves in varying degrees. If I go to the create a CV curve tool and I go to its options, you can see I can create a linear 1-degree curve, a 2-degree curve, a 3-degree curve, a 5, a 3, a 5, and a 7-degree curve. Bezier got in the way there. So anyway, 1, 3, or 1, 2, 3, 5, and 7. Now, once again, in Maya, the average user or even the expert user is going to make models in Maya to be used within Maya to be used in the automotive or in the entertainment industry, and they don't need to have the precision and accuracy that you would need in the automotive surfacing, for instance. And so the reason that degree 5 and 7 is included in Maya is that it's used in those applications. So once again, if you're moving a model between Maya and one of those high-end automotive surfacing applications, you have the support for 5 and 7 degree. Second degree is also used in those applications, and basically the higher the degree, the better the precision of the curve or the surface. And so in Maya, we really only need two of the 2 degree curves. We're only going to use 2 of these options here. One is the linear, and if I very quickly come in here and select linear and start to make a curve, you see I call this the jaggy curve. So basically it just goes point to point to point. And one thing that to note is that the degree of the curve, in order to actually have a curve, you need to have one more point than the degree of the curve, because we can't have a 1 point line. So for a 1 degree curve, I need to draw the second point, and as soon as I draw the second point, I start to draw a line. So I only need 2 points to describe a segment of a 1 degree curve. If I go back here and I switch this to a 3 degree curve, I'm going to need 4 points before I can start to describe a segment of that curve. So 1, 2, 3, and now when I draw the 4th point, there you go. It describes the first segment of that degree 3 curve. Now, the other thing to note is that CVs don't have to lie on the curve. Edit points do lie on the curve. Okay, so let me go back and pick this curve again, and you can see on this curve I've got 1, 2, 3 edit points, which are lying right on the curve, and the CVs don't necessarily lie on the curve. Think of the CVs as magnets that in the case of Maya, they all have even weighting of 1, and the magnet itself, if I go here to its CV and I grab that CV right there and I move it, it basically the curve is pulled towards the CV at that point. So that's kind of what the CVs are all about. It's just a different way of describing a curve. In a Bezier curve, all of the CVs, or all of the points, edit points, lie on the curve, and you have these weight handles that you can jiggle around to control the curvature of the line. So it's just a different mathematical way of describing a spline or a curve. So now, what is the importance of rebuilding, and why do we have to worry about it? Well, the first thing is this curve, you can see if I go into its attributes, is a uniform curve. It has a nice even min value and a nice even max value. You can see that it has 2 spans. If I turn off display of the CVs, you can see I have 1 span and 2 spans, and the number of or the min and max value, are the number of parameters, goes from 0 to the number of spans, which is 2. You can also set this to go from 0 to 1, and it just all of the intermediate parameters will be some fraction between 0 and 1. I like to use 0 in spans just because I just like the nice even numbers rather than thinking about things in terms of percentages or decimals. So if I come into this thing, let's show what this parameterization is, demonstrate it. So if I come in here and I add a curve point right here, and then I come down to the Edit Curves menu and I detach this curve at this point, I now have 2 curves. One curve has 2 spans, you can see right there, but it's no longer uniformly parameterized because it goes from 0 to where I selected the point on that curve. And once again, this originally went from 0 to 2, so this would be from 0 to 0 to 1, going to this first edit point, and I've gone just a little bit past it, so you see that it's ending at 1.1. What is that? 1.140. My diabetes is kicking in. My vision's getting blurry. But if I come here and I pick this curve, you can see it has 1 span, and it goes from where the first curve left off, which is 1.14, and it ends where the original curve ended, which was 2. So both of these curves are no longer evenly parameterized. And in the case of curves, it's a little hard to describe how that is a bad thing, but tools that you will use, and when you edit curves in Maya, don't like when you get odd behavior when the two things that you add, let's say if I attach these, if I detach things and cut things and trim things, and then I try to reattach them, and they have different parameterization, you'll get odd results. And I'm going to demonstrate that really quickly. So just very soon. So bear with me for a second on the curve here. So to demonstrate what rebuilding of a curve does, though, because a lot of people mistakenly think when I rebuild a curve it evenly distributes, because it's uniform. They see uniform parameterization and they automatically think uniform distribution of my CVs, and that's not really true. What uniform or what rebuilding a curve or a surface does is it ensures that the edit points along the curve, the parameterization along the curve is made uniform, or is made to be evenly distributed, not necessarily the points along the curve. Rather than sit here and drill myself deeper into this ditch, let me actually show you what I'm talking about. So let's come up here and go to Display NURBS CVs. So look at where the CVs are right now. Right? I have a CV here, a CV here, a CV here. It's not on the curve. All the things that are not on the curve, and a CV down here. And look at where the edit points are. I got an edit point here, here, and here that are on the curve. So if I come up to my rebuild curve option here, watch, the CVs won't move. What moves is the edit points along the curve, because when I cut this curve, these edit points no longer are guaranteed to be uniformly distributed along the curve, or in other words, they're not evenly parameterized anymore. I've got uneven parameterization. That was the phrase I was searching for. And so what will happen is when I come in here and I say, let's do a uniform build, there's different ways that you can rebuild these things, and once again, most of these are the only one that's really kind of important is curvature. That will rebuild the curve and guarantee that you don't change the curvature of the curve, and it will add points as necessary to ensure that the curve does not change when you reparameterize it. And then uniform is the other one that I use. Reduce allows you to reduce the number of CVs in a curve, which I hardly ever use. Match knots just says that I can take two surfaces or curves, and I can pick the first curve and then pick a target curve and then do match knots, and it will rebuild the curve and match a second curve. Those are the main ones to think about here. I'm actually at 12 minutes. No, I'm just going to drill through here. We'll go to at least 15 minutes before I stop if I have to, which I probably will, because I'm actually coming up on 13 minutes. So anyway, continuing on, I've got this thing separated, and what I want you to watch is this edit point right here, and watch this curve point. Watch all the curve points if you can. The curve points, the CVs I should say, will not move. It's only the edit points that move along the curve, and what that's doing is it's just ensuring that the edit points are uniform or evenly parameterized, which is what we want to do. When I cut this curve, I no longer had even parameterization. So when I hit, I want to do uniform distribution. I'm not going to talk about all these options, but pick CVs. That just rebuilds the curve with the existing number of CVs, and it evens out the parameterization to make the curve evenly parameterized, is the only way I can describe it. And what you want to look at here is you see this curve is ending at one point in a fraction. Whenever you see this thing ending in a fraction, that is your indication that this curve is no longer evenly parameterized. You want it to always start and end in a nice even integer value. And so now when I hit apply, once again, watch the edit point here. See what happens? Now the curve changed a little bit because that's what happens when you use uniform. If I wanted to ensure that the curve didn't change, I could do it with curvature, and it would actually add knots in there to maintain the curvature of the original curve. But let me undo that Z so you can see. So what happens, you notice, whoops, Shift Z. So what's happening here is make a note of the fact that the CVs do not move. They do not redistribute themselves along the curve. Only the edit points are redistributing themselves. And the only reason the edit points are redistributing themselves, even they aren't evenly distributed, if you notice. The edit point jumped up to here, which is, if it was evenly spreading itself out, your edit point would jump up to there. So it's not evenly distributing itself, it's just redistributing the edit points such that the parameterization along this curve is now uniform, and you can tell that because now my min value is 0 and I ended a nice even max value of 2, which matches the number of spans in my curve. And if I come down here and do the same thing with this one, you see it's one span, and it goes from, it's not uniformly or evenly parameterized, but if I come in here and I just rebuild it with CVs and uniform, boom, now it doesn't change at all, and it goes from 0 to 1. And if I undid that just very quickly, but I turn on the CVs, let's see if there's any change that's going to happen there. NURBS, CVs. Okay, so, well, in this case it won't, because see, I got an edit point here and an edit point here, and neither of these two edit points can move. They're pinned. So when I do this, you literally won't see anything happen other than the parameterization gets fixed. Right? See, so there you go. Now it goes from 0 to 1. So both of these are now evenly parameterized. And when I connect them together and I edit them, once again, if I connect them together, what I want to do is once again rebuild the curve, because connecting curves together will mess up parameterization. Cutting curves, trimming curves. Anytime you add a point to a curve, it changes its parameterization, and you need to rebuild it. One of the ways that you can change a curve's parameterization, but it's not obvious, is if I come into this curve right here and I add a curve point right there. The starting point and the ending point is even. You don't know what the parameterization of any of the points in between are. So if I inserted the point right there, so if I come down here and go to edit curves and I do an insert not, right, I've just added an edit point into my curve, but you see my parameterization still looks like it's nice and even. The way you can tell that it's not uniformly parameterized, though, is notice that my max is not equal to the number of spans in my curve. So this, although this, you've got nice even numbers up here, you are not evenly parameterized on this segment of this curve right now. So if I hit rebuild here, you'll notice that it now goes from 0 to 3, and it matches the number of spans. And if I undo that, it didn't really change the shape of the curve very much. It just moved, once again, the CV stayed fixed. Only the edit points distributed themselves. So if I apply that again, boom, you see the edit points distribute themselves. And that's just changing the parameterization of the curve. So that's parameterization on curves. Now, why is rebuilding curves, particularly surfaces, important? So down here, I have two planar surfaces, and this is going to go 20 minutes, guys, minimum. I'm sorry I'm being so yabbery. I don't know. Anyway, I got two planes that I've created here. They're NURBS planes, and they look to be 4 by 4, and they appear, for all intensive purposes, to be exactly the same. They're 1 degree. Come in here, you can see that this guy is a 1 degree. It has basically, think of it as curves that are running in two perpendicular directions. There's the U direction and the V direction. And so if I was to think about moving up this line here, and there's a curve here, and then there's a curve here, there's almost like an infinite number of curves that are running up along here that describe the surface going in this direction, and there's once again an infinite number of curves that are running this direction in the V direction that describe the surface in that V direction. So you can actually have curves in one direction that have differing degrees. In this case, the V curves have the same degree as the U curves. You can see the degree in U and V is 1 and 1. My spans in U and V is 4 and 4. Since this is a 1 degree surface, it's going to have an, it's got, you can see 4 spans right here in V and 4 spans in U. And then in the maximum range of my curves that run in the U direction go from 0 to 1, so they're uniformly parameterized, and likewise my spans that go from in the V direction are 0 to 1. Now the thing you'll notice here is my max value is not matching my spans, and once again that has to do, the reason for that is it has to do with the way that I created these surfaces, and that's why I like to create my surfaces when I rebuild them. I like to rebuild them from 0 to span. You can pick that right here. You see when I created these guys I rebuilt them 0 to 1, and I should have built them 0 to span, in which case this number would go from 0 to 4. Okay, so that's why it doesn't match up with what I was talking about. But let's see what happens here. I got this guy. They both are saying they go from 0 to 1, 0 to 1. This guy right here says it's going from 0 to 1, but oh, wait a minute, this one's going from 0 to 0.8. So in my v direction this way, my parameterization is 0 to 8, but if you look at the patches, they look to be the same. And so the problem is, the way that I created this one that's not uniform is I came in here and I went into isoparm and I added an isoparm right there, right? And then what I did is I took it and I went to edit surfaces and I said detach, right? Detach surface right there. And that split this into two surfaces, and then I deleted this surface, so now I have a surface that has the same number of spans, 4, and then I took all of these points and I just spread them back out so that I made this patch look like it matches this patch, but the parameterization is different. And here's why rebuilding your curves or surfaces is important. If I take this this surface and this surface and I try to attach the two together, edit NURBS, and I do an attach right there, boom. Oh boy, you see you get this really wacky 1, 2, 3, 4, 5, 6, 7. It went from what should have been 4 by 8 by 4, or what? No, yeah, 4 by 8, and it turned into this wacky 1, 2, 3, 4, 5. Looks like 6, 7 by 1, 2, 3, 4, 5, 6, 7, 8. So in the direction where the parameterization matched, it stayed the same, and the isoparms, in fact, stayed evenly distributed. But in the direction where we had mismatched parameterization, the isoparms got all whacked out. And once again, now you can see that this thing really has wacky parameterization because it says it's in this direction, it's only going from 0 to 2, right? Which clearly doesn't match the number of spans in U. There's 8 spans in U, but it's telling me that the max value is only 2. And this guy, even though once again you got even numbers for max and min, it's nowhere close to matching the number of spans in the v direction, which is now 7, which should be 4. So let's undo this and show why, and I promise this will actually wrap it up. This is the big finale. Why is rebuilding important? So let's take both of these guys. Let's take these lines. We don't need these curves. We don't need them anymore. Let's take both of these guys and duplicate them and pull them up. Okay, and now let's take this guy is perfectly fine. It goes from 0 to 1, 0 to 1. Let's actually rebuild it. Let's once again, just like with CV, or just like with curves, you can say match CVs, and it'll just rebuild it with the number of CVs that it has, and then let's make it uniform, and let's go from 0 to spans this time, and now click it. It doesn't change at all, and now you just see that its min value and max value. The max value matches the number of spans. That's why I like to use 0 to span, because at a glance I can see if at least the end conditions are the min and max values are integer values, and that the maximum value matches the number of spans. If those two conditions are met, you pretty much can ensure that your patch is uniformly parameterized. Going to this one, let's rebuild it. Now here it's a fraction, but I'm going to rebuild it to CVs again, so it should change to 0 to 4, 0 to 4, and not change its position at all. So nothing changed. It looks exactly the same, but now it's uniformly parameterized, and the max values matches the number of spans in both U and V. So now remember, when I came and I picked these two guys with mismatched parameterization, and I did an attach, edit NURBS, attach, bad, ugly, not good. Now I take these two guys and I'll do the same thing. Now that their parameterization has been rebuilt and matched, I can come down here and I can say attach, and voila, that's the big finale, guys. So there's why you want to rebuild surfaces when you're cutting and attaching them. So basically the rule to remember is this: when you're editing surfaces, NURBS surfaces, and you either insert isoparms or you remove isoparms or you trim surfaces, immediately you should immediately rebuild the surfaces with the CVs using this CV option right here, so that when you later attach them, you get proper parameterization and you get predictable results. Once again, this guy went from what should have been 4 spans, and we started out with 2 surfaces that had 4 spans in V, and we ended up with a surface that had 7 spans in V. Here we started out with a surface that had 4 spans in V, 2 surfaces with 4 spans in V, and we ended up with 2 surfaces with 4 spans in V. So anyway, we're actually at 25 minutes. I'm sorry about taking so long, especially since the last 40 seconds pretty much described everything. I want to thank you guys for sticking it out if you made it to the end of the video here, and I hope this helps you guys to not be so afraid of NURBS surfaces. I think they're very powerful, and they're really underused in Maya, but because a lot of people are afraid of them, they don't understand things like this parameterization. And I hope this video helps you guys understand it a little bit better and not be so afraid of NURBS. And thanks for listening.